We do it together as a team, as a group. Homework number 2. So on homework number 2, question number 5, because of that storm, it's thrown us off a day. So now we're already back behind a day. I apologize, but originally we should have been able to answer this question. And originally we should have been able to answer this. But we couldn't. The storm, and these were already out, right? Our notes were already printed. Our homeworks were already printed. Our calendar was already done. I did revise the calendar a little bit, but there are still a few bumps and hiccups here and there because of the storm. So homework question number 5, I apologize. I like how some of you really thought about it, and I like your thinking. But those steps that you took were kind of a lot, but you really thought about it. I'm going to help you get to this in a simplified way as soon as we get to that last 2 pages of notes. But unfortunately, we should have, but we didn't. Okay? We didn't get to this part. We should have, but we didn't. Okay? We should have got to this section on yesterday, Thursday. That's what we're going to do today. So let's go ahead and let's look at what we are able to do. We are able to do question number 1. Question 1 says that you're going 50 meters per second, then later you go 10. Find the change in. When you see the word change in anything, you've got to think subtract. Okay? When you see the word change in anything, your brain goes to subtract. What do I subtract? I subtract the final minus my initial. My final was 10. My initial was 50. Okay? So then I'm going to get 10, take away 50, and some of us got the right answer, but some of us were still kind of wrong. Because some of us just found the difference and didn't actually put the numbers correctly. Some of us actually did 50 take away 10. Don't raise your hands, but you know who you are. Look at your paper. You did 50 take away 10, and you just gave me 40. The equation for anything to find the difference is final first. My final is 10, my initial is 50. 10 take away 50 is negative 40. That's your answer, not positive 40. Okay? Final first. Final first. All right, let's keep going. The next one, number 2. An object is going 4 meters per second. If after traveling for 16 seconds, okay, here's my t, it starts to go, final velocity, 12 meters per second. Initial velocity. Find the acceleration. My acceleration equation is final velocity minus initial velocity over time. And most of us had this without a problem. 12 take away 4 over 16. 12 take away 4 is 8 over 16 equals 0.5. What's my SI unit? Meters per second square. Okay, I even saw that. Most of us got that without any problems. Okay, the next thing. An object moves 16 meters in 6 seconds. Find the velocity. Here's my t, here's my distance. V equals d over t, or 16 over 6. 2.66667 something or whatever meters per second.
So I put 2.7 repeated, so one on top, that counts?
That counts. That's pretty good. I'm good with that. What if it was a multiple choice question, A, B, C, D, and it was 2.6? I mean, that's the one you would probably pick. All right, that works too. The next one, though, says number 4, an object, it says here, accelerates. Now, if this is my A for acceleration, what type of acceleration is it? It's a positive value. Positive acceleration means to speed up. Means that my first number is whatever, but my second number better be bigger because it was speeding up. Let's keep reading. For 10 seconds. If it starts at 4 meters per second, VI, how fast, VF, is it going afterwards? This question probably started to really mess some of us up because you were probably trying to do A equals VF minus VI over T, which I agree. That is the correct equation. But if you did not algebraically solve it correctly and do all the steps, then you got it wrong. Let me tell you that I like to cut back on my algebra because I put this into the triangle. Miss Munson, I've never done this triangle stuff. I hear you. But if you start it now with me, it's going to make your life simpler. Let's cover up the equal. VF minus VI. That's at the top of the division. T is at the bottom, so T has to go at the bottom. Remember, this line means division. This line means multiplication. Most algebra teachers do not teach the triangle because it takes away from their students doing the algebra steps, if that makes sense. This is like the shortcut algebra. This really simplifies it. What's left over is my A. What am I looking for? I'm looking for the VF. Let's cover that up in my equation. My equation is going to be A times T. Now let's see what this is. VF minus VI equals A times T. Now let's plug in our numbers, and now let's go ahead and do our algebra. Because this way I can cut back some steps. VF is my question mark minus VI is 4 equals A is 3, T is 10. 10 times 3 is 30. VF minus 4 equals 30. Add 4, add 4. I'm just doing basic algebra. VF equals 34. But wait a minute. Meters per second. And take a look. What happened? My object has a positive value here. What is a positive acceleration? It means speeding up. So if I started off at 4, then that means my final velocity better be bigger than 4. And it is. It's at 34. That's what I need us to start thinking about, because as we continue in physics, I need you to kind of already visualize what my answer is going to be. Okay? We skipped this one because we just didn't get to it. We should have yesterday, but the storm slowed us down. The next one. It asks you, well, what's going on the x-axis? Time. What's going on the y? I had somebody earlier, Jesse, say position, but in last period, another student said distance because of the M. So my question, Jesse, is on the y-axis, is it position or is it distance? Because we need to know that, because later on quiz or test day, I don't want us to get confused.
I would assume it's supposed to be distance, but they put position on this.
Okay, and so assuming that they have a distance, but yet they wrote position, we can assume that both of those two words mean the, thank you, exactly. So it doesn't matter which word you wrote, distance or position, but in physics, position and distance or displacement all mean like the same thing, okay? And I just want to make sure that we're all on that same page. The next one, number 3, how far does the object move if the object started over here to over here? So that means that we're going to go from here to here in this section looking at the Y. What'd you get, Jesse?
6 meters.
I did too. How much time did it take from here to here? I got 2 seconds. Then it asks you, put this information together. What does it mean? That question, some of us were confused. Well, let's go back. When you're looking at graphs, you have to read the X and Y axis. And this is a distance or displacement versus a time. What does distance versus time from your notes set tell you? What does it mean? From your notes. We talked about it yesterday, your notes. Y'all have your notes out, right? Because we're going to do notes in a minute anyway. So, right, we always need our notes out. But we talked about graphs yesterday, and on the y-axis, we had distance, and on the x-axis, we had time. And on the top, before we started those notes, we talked about what does it mean? Reese, what does it mean? What is this? What is this? When I put all of this information together, what is it telling me that the object's doing? What is it's the object's
Speed.
Thank you. Speed. That's what the answer is. So write that in, because a lot of us got it wrong. Speed. A DT graph tells me the speed. Now the next one, what's that? Number 6. A lot of us got this one wrong. Let me go back. Day 1. Everything in physics is broken into 2 categories. They are either going to be a vector quantity or a scalar quantity. So Sophia, what kind of quantity is this? Now we got it. Write in the correct answer because most of us got it wrong. But are these notes coming back? Things that we learn here is going to come back later on. Quantity, a scalar or vector. All right, let's move that out the way.
Ms. Munson, what's number 5?
We're not talking about that until we get to our Super Power Ranger morph equations, which won't be for a little bit. But hold on to that one so that way we can talk about it. That way you can go back and look at it. Our notes. Get your 5 different colors out. All right, you can use whatever colors you want, no problem. Just know that when I'm talking and using my colors, those are going to be my colors. Your colors are your colors. I'm going to use pink. I'm going to use, oh, this one's dying on me. Let's see. That one's not good. Did Reese tell you that you took all the good colors? What? Oh, golly. I mean, stab him in the heart. Make him feel bad. All right, that's all right. That's his fault if he doesn't have better self-esteem is what she said. I'm going to use orange, pink, green, and blue. You use whatever color you want to, but just make sure in a moment, if you use different colors, then it may not make sense. But you can use whatever colors you want to. All right, so we're starting off with, guess what? 2 students, last class period. Look at this. There's this page, and there's this page, and they look exactly the same. At rest, constant speed. At rest, constant speed. She was and the other person were on the wrong page, and they did the whole thing, and they were completely wrong. So we're starting off on, look at your top, distance, time graph. Please make sure you're at the right graph so you don't mess up. We're at distance, time graph. And what does a DT graph tell us? It tells us the speed of that object. So step number 1, before we do anything, let's go ahead and on our DT graphs, we're going to 1, 2, 3, 4. We're going to make little graphs over here. Graph number 1, graph number 2, graph number 3, and graph number 4. All right, there's a couple of collegiate high school students that never took me for physics, and they're gone straight into the other physics class. Not a good idea, because now they're doing this same exact thing that we're doing, but the teacher doesn't simplify it. I'm telling you, I'm going to simplify your life. If you think that you might take any other college classes, and it might be something with physics or math, you might want to hold on to these graphs, because they're going to correlate either way. Let's keep going. We're going to call this one rest or stop. We're going to call number 2 constant speed. Number 3, speed up. And number 4, slow down. Okay? So those are my 4 graphs. One thing that I have as a suggestion is I would brain dump this page and the next following page. Those are 2 things that I would definitely brain dump. So let's go ahead and let's start off with rest. When we're talking about a DT graph that's at rest, my line could be a flat, straight line above the x-axis. It can be a flat, straight line on the x-axis. It could be a flat, straight line below the x-axis. It doesn't matter, but there is no slope. Okay? The next one, I'm going to use blue. Now, if you see a direct relationship line, that means that my object is moving at a constant speed away. If you see an inverse relationship line, then that means that my object is moving at a constant speed back to the origin or back home. Away from the origin, back to the origin. Speeding up. I'm going to use pink. You can have a speeding up look like this or like this. The first one means that it's moving away from the origin, speeding up away. The second one, it means that it's speeding up back to the origin. The last one, I'm going to use orange. To slow down, to represent a slowing down graph for dt, because they're all dt graphs, I can have a line that looks like this, or a line that's curved and looks like this. The first one means that it's moving away from the origin or back to the origin. Okay? But Ms. Munson, that homework didn't make any sense at all. I hear you. But once we color code this, if I was you on test day, I would be having my same colors too in front of me to help simplify my life. But let's go ahead and let's start off with reading our questions. We are going to read the questions. Every time we see a word that correlates with rest or stop, constant speed, speed up or slow down, we're going to color code it. For an example, number 1 says that my object is at rest the entire time. And so I'm just going to box it in green. And that's it. I'm only going to use green because the entire time it was at rest. But number 2 says that it's at a constant speed and then suddenly stops. Okay, what is constant speed? For me, it's blue. So let me box that in. Constant speed. Stops is green. For me. Okay, makes sense now? Let's go ahead and let's read number 3. Gradually slows down. Whoa, 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 whoa. Slows down is orange for me, but does not stop. Okay, so slows down, that's it. Does not stop, so don't add green. Number 4, slows down. Okay, that's orange. Comma, stops, that's green. And speeds up. Oh, okay, well that's pink. 3 colors on number 4. Okay, so let's go ahead and let's keep going because now you know what we're doing. Let's keep going. You do number 5 through 12. I'm going to do them up here. You do yours. Let's get them done. Constant speed. And then speeds up. Pink. Use your colors. Number 6, speeds up the entire time. Constant speed, that is not 0. That's blue for me. The next one. Ooh. Look at 8 real quick if you haven't got there. It moves towards the reference point. The word reference point is the same thing as saying towards the origin or towards home, and then comes to a stop. I don't have a clue if this is fast or slow or constant speed. I don't know. So I'm going to underline it in black, but I am going to box this in blue though. Okay?
Green.
Oh, green. Oh, sorry, green. Green. So that was kind of different. Number 9, gradually slows down to a stop. Slows down is orange. And then stop is green. 10, constant speed, blue. And then slows down, orange. speeds up, pink, and then suddenly stops, green. Multiple constant speeds. If you haven't got to 12 yet, there's a key word there. Multiple constant speeds. So I'm going to underline the word multiple. And I'm only going to box it in blue. Give it to me.
I have a problem with that.
The word multiple?
That whole statement.
Number
Multiple
12?
constant speeds that increase in value, isn't that just speeding up?
No, because why can't you have an instantaneous speed of this speed, and then all of a sudden this speed, and then all of a sudden this speed, and all of a sudden this speed?
There's speed ups in between the constant speeds.
No, it doesn't. Okay, sure.
Right? There's multiple,
I don't really understand.
speed ups in between the constant speeds, right?
Wait till we get there. All right, so for those of us, I'll give it like another 30 seconds. Hopefully we're all done with all 12. Anybody else? I think there's a couple more that are finishing up. So finish up your 12. Give it a few more seconds, because some of us are so excited to get to the next one. All right, here we go. We're going to color code our graphs now, okay? When we color code them, let's look at this one for an example, green. Green is a flat line. I don't care if it's on the X, above the X, below the X. It's a flat line. You're going to come to all your graphs, and you're going to find all of your flat lines that are not slopes, and you're going to go ahead and box them in green. Box them all in green. Is there any, oh, whoa, look at D. D, right there. Flat line, flat line, flat line. We're missing one. What letter? I'm missing a flat line, a rest. No. Pretty close though, but no. Not K. C. Right there. Right there. It almost looks, yeah, I mean, K is so close too. Believe it or not, it's C. Now let's go ahead and let's look. Anytime you find a nice straight line, whether it's up or down, we're going to box it in. And for me, it's going to be blue, like B. E. Oh, look at L. Just one straight line. F. But wait a minute. Oh, what's another word? More than one? Oh, there you go. H. K. That's it. Next one, speeding up. For me, it's pink, but it's going to be a curve like hit this or that curve. For an example, D. H. M. All of M. Yeah, I agree with you. N. I agree. The last one is slowing down, which is one of those two curves, which is A. All of A. Sorry. I agree. C. D. I agree. D. K. Okay. All right. I mean, I don't know how much easier to make physics. For those of us who come in with that misconception that, oh, I'm not going to be good in this class, I'm forced to take this class, I have to take it for credit, blah, 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 blah. I'm telling you, I promise, I try to simplify this. Let's look at the first, let's see, Sophia, pick a number 1 through 12, except for 8 or 12. 7? 7. What color is 7 colored? Blue. Is there any other colors other than blue? No. Okay, so which graph is only blue? Okay, so not 7, not 8, not 12. Pick another number. 3. 3 is orange only. Which one is orange only? A. 3 is A. Look at number 2. 2 is, look at this though. First blue and then green. Which, whoa, you're fast. Okay. There we go. E. But does this not make sense? I mean, color coding, I mean, you can't. Look at number 4. Orange, green, pink. D. How are you going to make a mistake now? I mean, I guess if, I don't be rude, but maybe if you're colorblind. But, I mean, I don't want to be rude, but other than that. Oh, what happened?
Why couldn't 2 be B?
2BB?
Yeah. No, because it goes from slowing down to stop. Okay, I get it.
Okay. But let's go ahead and let's look at that 7, 8, and 12. Okay? 7 says constant speed that is not 0, but yet 12 says multiple constant speeds. Could we all agree that a constant speed that is not 0, for an example, number 7 is going to be L? It's just one constant speed. But 12 says, what's that word again? Multiple constant speeds. He's got to be F. That is one speed, and that's another speed. Instantaneously, it went from this speed to that speed, instantaneously. There was no gradual increase in speed. It was this and then that, automatically. Okay, next one, 8. It moves towards the reference point, okay? Towards the reference point would be a downward line, or it would be a curve like this, or it would be a curve like this, and then suddenly stops.
B.
Say it again.
B.
B. 8 is B. 1 is O. 5 is H. Keep going. You can't mess up. Now that we understand it, what the words mean and what the shapes mean, we're so gonna get this. This is great. So when you're ready, we're turning the page. Please make sure you got all the right answers. There's the answers. Double check them. But this is good stuff. Turn the page though, because this next page is a VT graph. Now we need 5 colors. So this is a VT graph. And what does a VT graph tells you? It tells you the object's acceleration. Okay? The object's acceleration. So on a VT graph, we need 5 colors. We're going to have our first one, graph number 1 for my VT graph. My second one, VT graph. My third one, VT graph. My fourth one, VT graph. And my fifth one, VT graph. Okay? I'm going to go with green, blue, pink, orange, and yellow. All right, these are the colors I'm going to go with. First one. Let's label the first one at rest or stop. Number 2, away from the origin at a constant speed. Away from the origin at a constant speed. Number 3, back or towards the origin at a constant speed. Number 4, accelerating. And number 5, decelerating. Or slowing down. Right? Accelerating or speeding up, or decelerating or slowing down. So let's go ahead. I'm going to have my rest green. But when it comes to a VT graph, for it to mean that the object is literally moving 0, It's not moving at a constant speed. It's not maintaining cruise control. It is literally at rest. The line is only gonna be on the x-axis. Only on a VT graph. Only on the x-axis. Now, if it's moving away at a constant speed, it will be a flat line, no slope, anywhere above the x-axis, depending on the velocity. The faster it is, the further away from the origin, okay? But it's gonna be above the x-axis. So moving back towards the origin at a constant speed is going to be below the x-axis. If it's going to accelerate, it can accelerate above the x-axis or it can accelerate below the x-axis, but it's going to be a direct relationship line. The one above the x-axis means that it's accelerating away from the origin. If it's below the x-axis, it means that it's accelerating back to the origin. And decelerating is going to be an inverse relationship line, above or below. Again, above is away, and below is going back to the origin. All right, we've got the same things to do. We're going to go ahead and color code our number 1 through 12. Then we're going to color code our graphs. Here's where students start to get a little like, something's wrong, Miss Munson. Look at your graph on letter K. Something's off. Why is there a line here and then all of a sudden there's a line here? There's no line connecting them. There isn't. Because on VT graphs, all of a sudden my line can be here, then it can be up here, then it can be down here, and then it can be on the X, and they do not have to connect. If you want to, sometimes you'll see them where there's just a line that goes straight up, and that line right there is connecting those two. You don't have to do it. Sometimes you see it like this. Sometimes it might be missing and just not even there. Okay? So let's go ahead and color code them. You start your color coding, I'll start my color coding. Alrighty. Green. Constant speed.
So when it says constant speed, how do you know which one is pink or blue?
So, I'm going to underline it for right now. But I do know that it suddenly stops. I agree. How do I know? That's one of those weird ones. Remember the last page had multiples? So I'm going to leave that one there underlined. Something's off with that one, fishy. Number 3, gradually slows down but does not stop. So the word slowing down is decelerating, orange. Slows down, orange. Stops, green. Speeds up. Which one?
You're yellow.
Yellow, okay. I got confused for a second. Yellow. Okay. Constant speed. Ooh, there it is again. You see it, Bailey? Underline it. And then speeds up the entire way. Okay. Number 6, speeds up, accelerates the entire time. Constant speed. That is not 0. I don't know. So I'm just going to underline that. Number 8 moves towards the, oh, there goes one. 8 moves towards the reference point or origin, then stops.
It could be accelerating or decelerating.
Thank you. But stops is, for me, it's going to be green. For you, might be something else. Gradually slows down to a stop. Well, stop is green. And decelerating, yep, that is decelerating. Constant speed, and then gradually slows down, so slowing down is orange. And constant speed, I don't know if it's a way or, so I'm going to underline it. Number 11, speeds up and then suddenly stops, so that's yellow. And then green. Multiple, constant speeds. That's 2 underlines. So the truth of it is that VT graphs are definitely trickier than DT graphs. They are, okay? But let's go ahead and let's color code your graphs at the bottom. If it is on the x-axis, like letter A, then it is going to be green. Letter C, green. Give it to me.
So this is speeds that increase in velocity. Why wouldn't that be the same?
Which letter? Which number? 12. Multiple constant speed that increase in values.
Why wouldn't that be the same?
Why won't it be? I'm listening to you. Got you. At first I was trying to think of the words. It's multiple constant speeds that increase in value, meaning that, let's just say there's 3 of them. This constant speed is 2, then it's going to increase in value because this constant speed is 4, it increased, and then this constant speed is 8. So it's multiple constant, it's not acceleration, it's just that the constant speeds were different values and they were increasing themselves. Okay, so let's go ahead and let's keep coloring. I got green, I got rest on E, I got rest on L, I got rest on O, and I got a rest on H. Okay, I got acceleration on letter E, acceleration on F, H, M. I got slowing down, deceleration at B, D, H, and L. I got constant speed back towards the origin below the x-axis, letter A. That's it. Blue, constant speed away from the origin, B. Look at K, multiple, and they increased in value, N, O, M. Same thing here. We're going to go ahead and we're going to color code it to match your questions above. For an example, number 6, it is yellow the entire time, which is letter F. They correlate with each other. Number 1 is green the entire time, which is C. Next one, 3 is orange the entire time, which is D. Makes sense to us. Let's do the ones that we had to underline last, so that way we can, really analyze it. But let's do the easy ones first. Orange, green, yellow. Orange, green, yellow. Orange, green, yellow. Oh, H. 4 is H. 9 is orange, green, which is L. 11 is yellow, blue, in that order. Yellow, green. E. All right. So here are the ones that had no underlining done. Now let's go back and analyze the other ones. Number 2, constant speed and then comes to a stop. I know that it has to have it has to be either blue or pink and then comes to a stop. Say it again. O is correct. Constant speed and then speeds up. So it has to be 2 things. The second one is going to be yellow. Elm is correct. At least we have it color coded to help simplify it a little bit. The next one, constant speed that is not 0. N is the correct answer. 8, it moves towards the reference point or origin, and then it comes to a stop, which means that for me, green is going to be the next thing on there. So A, which is pink, and then it's green, because I have to have one that's green at the end. A. 10, constant speed and then gradually slows down. B. Multiple, oh, there we go. K. Multiple constant speeds, and the second one is faster. Okay. Making sense a little bit? No, this is a heck of a lot easier than any other teacher that teaches in this classroom. We'll simplify it for you. Here's what I suggest. I suggest this side and the other side become those little things that you're going to brain dump because they're going to help you out. On that homework number 2, on that back side, I'm not expecting you to do it. Like I'm not going to grade it, but now you can go back and do this now on your own to practice because you're going to be quizzed and test on it. When's your first quiz? Tuesday with your VT graphs, DT graphs. I would practice this. I would practice that.